All right, so example 3 says to perform the indicated operation, and whenever it says assume that all expressions are defined, that means you don't have to list the restrictions, okay? So yesterday we did have to list some of the restrictions. It was whenever you had a denominator with a variable in it, remember you had to set the entire denominator equal to 0 to figure out what values of x would make the denominator 0. We talked about, oh, we have to use this step because even if we have 0 over 0, that's a indeterminate value and we wouldn't be able to simplify. Also yesterday, we did some simplifying with monomials. Okay, so in A, we're multiplying, but we have all these monomials. You can simplify the numbers right away if you would like. Usually that's what I do because then you're working with some smaller factors. So 3 is going to go into itself once. It goes into 9 3 times. So I replace those right away usually. You could also multiply across. For this, 2 goes into itself once and it goes into 10 5 times. And now I can multiply straight across. So 1 times 5 is going to be 5 on the bottom. 1 times 3 is going to be 3. Now in terms of variables, we're going to write some of our rules up here from Algebra 1. Okay, the rule is if you have the same base and you are multiplying those together, what do you do with the exponents? You add them. Okay, so that means if I multiply x to the 5th times x to the 3rd, what do I have? I should hear more than one person. What do we have? X to the 8th. So we're adding those together. And then, Chris, how many y's am I going to have?
You're going to have 7.
Good. And then I'm going to do the same thing in the denominator. So, Kelsey, how many x's do I have in the denominator?
5.
Good. And Gigi, how many y's? I think more than that. 7 and 5?
Oh, 7. I'm sorry. 12.
Yes, good. All right, so now I can reduce my variables here. So your objective is you only want one x, you only want one y, you only want one of each variable. So if you are dividing and you have the same base, what do we do to the exponents?
Minus.
You subtract them. So when you're multiplying with the same base, you add. When you're dividing, then you can subtract. Okay, now I'm going to keep my 5 on the top, my 3 on the bottom. 8 minus 5 is 3. So x cubed is going to go on the top. If it's positive, that goes on the top. On the bottom, I am going to have 7 minus 12 for the y's. 7 minus 12 is negative 5. Whenever you have a negative, so let's say I had a to the negative m power. Do you guys remember how you simplify a negative? It's the reciprocal, and you change the exponent to a positive. So if I had x to the negative 5, y to the negative 5 to make it positive, the reciprocal would place the y in the denominator. Okay, now I want you to look at the previous step and see if you can come up with a rule where you can check to make sure you put your variables in the same place, right, in the correct place. So what do we notice? All the x's ended up on top. All the y's ended up on the bottom. How does that relate to what we have here? Yeah, Ria?
If there's more x's on the top.
Exactly. So which exponent is higher, the one on top or the one on the bottom? On top for x. So x ended up on top. For the y's, the larger exponent was on the bottom, so that's where your y should be. So you can always use that to double check, okay? All right, why don't you try B? So you can use the same method I showed you, or if you want to try a different one, you can right, so like I said before, I do like to simplify with my numbers first. So I know 2 goes into itself 1 time, 2 goes into 20 10 times. Then I can also simplify here because 5 goes into 15 3 times, 5 goes into 10 twice. You can also multiply straight across. Okay, so you have 2 over 3. If you were to multiply straight across, then you would just have 20 over 15 times 2 is 30. And wouldn't 20 over 30 also reduce to 2/3? Yeah, so you can choose either method, okay? Now, in the one before, I didn't cancel out any of my x's. I just multiplied across. But if you want to cancel out some of the common factors at this step, you can. So this is an x, this is an x. I might cancel those out now because x divided by x is going to be 1. And then you'd be left with x to the 7th on the top, x to the 4th on the bottom. 7 minus 4 is going to be 3. So your final answer would be 2x cubed over 3. Okay, and I saw some of you guys wrote your answer like this, your x cubed on the side. That would be okay. Just be careful because if it is in the denominator, you can't write it like that. All right, for C, I have division. So there are different sayings when you're dividing fractions. What do you guys say to yourselves? Keep, change, flip. What's another common thing? Yeah, multiply by the reciprocal. And then sometimes I'll say skip, flip, multiply. So you skip the first one, you flip the second, you multiply them together. Okay, so that's what I'm going to do first. So if it's division, that means I'm going to multiply the first term by the reciprocal. So then this is going to flip. So I have 8y to the 5th on top now over 15. I do that first so I don't accidentally start canceling out values that cannot cancel. So the only time you can cancel them out is if you are dividing them. So if they're both in the denominator, right? If this was multiplication, I couldn't cancel those out because that would be 8 times 8, not 8 divided by 8. Here, I do have 8 divided by 8 because I'm multiplying by the reciprocal. And then 5 goes into itself 1 time, 5 goes into 15 3 times. Okay, so I'm just going to put the 1 up here as my placeholder, and then in the denominator I have 3. Okay, and I do like to multiply across. And then I'll have x squared, y squared on the bottom. So I have x to the 4th, x to the 2nd. More x's are on the top, so that's where this is going to end up. So I have x squared on the top. Because I have x squared on the top, I don't need that 1 as my placeholder anymore. So I'm not going to write the 1 again. And then 5 minus 2 is going to be 3. Okay, and then that looks a little funny with the center being off, so I'm going to center my answer. Okay, and again, this would be an equivalent answer. 1/3 times x squared times y cubed. Okay, questions for me so far? Yes.
Can the 1/3 be multiplied by the y too?
When you're writing your final answer, your variables should be in alphabetical order. Are you saying that you put the y cubed x squared, or?
I put x squared times 1/3 times y cubed.
I'm gonna look at yours. So don't distribute it to anything just because it is multiplication. You don't have any addition. And yeah, so you should have, like, your numeric value should be in front. Just like if you had like 2x squared, you wouldn't have x squared 2. Okay, and then for D, this is another one where it's division, which means you are going to end up multiplying by the reciprocal. Okay, so the first one is going to stay. Now we're going to flip. Do you guys like simplifying your numbers first too? Okay, and then you have 3x squared y squared on the bottom, x to the 4th y. I like to line these up just because sometimes they don't give them to you in the alphabetical order, so if you can line them up, it just makes it easier to subtract. So I have 3 on the top. So 2 minus 4 is negative, which means I have to make it positive and move it to the bottom. Based on what we just talked about, how wherever the larger exponent is, that's where the x is going to end up. I always do the larger one minus the smaller one because it's easier to do in your head. 4 minus 2 is 2 because the 4 is on the bottom. That's where the x's are going to go. 2 minus 1 is 1. Y squared is on the top, so that's where that has to go. Okay, so 3y over x squared is going to be your final answer for that one. All right, now for E and F, we are going to start by factoring. Again, notice that this is division, so we're going to have to multiply by the reciprocal. Okay, so these we are going to factor, and then we just write the things that you're looking for when you factor, those 3 steps, and then I want you to factor these. Okay, so I'm going to give you a minute to do that. Okay, so Kira, for the numerator here, what's the first thing that we do?
You can take out the GCF.
Good, and what is the GCF?
X squared.
Yes, and that is your first step. Okay, so you're looking for what they have in common. All right, and then Tyler, when you take out x squared, what do you have left inside there?
You have x squared minus 9.
Yep. What's special about x squared minus 9?
Squares.
They're perfect squares, right? That's your special pattern, your difference of 2 squares. So that I don't have to keep like writing out the whole thing over and over again. If you notice this factors down, I'll just write this above it. Okay, and then in the denominator, I have x and x has to multiply to 3, add to negative 4. Anytime you have a positive last number, the signs have to be the same. So we look to the middle number to determine if they're both positive or both negative. 3 is prime. The only things that are going to multiply to 3 are 3 and 1. And I don't have any numbers I'm multiplying in front of the x, so x minus 3, x minus 1. Now when you're factoring with this, you're using your guess and check. Okay, the guess and check means you're checking with FOIL. All right, and then here I'm factoring the x squared minus 16. Maria, what's that going to factor to?
X plus 4.
Good, that's our special pattern, x plus 4, x minus 4. Okay, Cam, what should I do first for this one?
Take out the GCF.
Good, so we're gonna factor out the x squared. Notice that the reason why I wrote this on the top is because you're multiplying by the reciprocal, right? So it's division. If it's division, these are gonna flip. So this is your reciprocal. When you take out the x squared, you should have x squared plus 2x minus 8, and then I'm going to see if I can factor that again. Don't forget about the x squared that's there, because sometimes if you factor it again, you can forget. This is negative 8, which means I have a plus and a minus. If I do plus 4 and minus 2, that gives me 4x minus 2x, which is 2x. 4 times negative 2 is negative 8. That works. Now you can start canceling out common factors so that I don't miss any. What I do is I just start at the top, and then I see if it cancels, and I just go right in order. So do I have an x squared? In the denominator? Yes. So cancel, remember, cancel light enough where I can read what is underneath it. Okay, so this simplified, so x plus 3. Is there an x plus 3 on the bottom? Nope. So then what I do is I write that down right away on the top. The x minus 3, is there an x minus 3 on the bottom? Yep. If there were 2 of them on the bottom, you can only cancel it out with 1. So that's something to watch out for too. Okay, x plus 4, is that on the bottom? Yep. X minus 4, is that on the bottom? Nope, so I'm going to write it on the top. And then on the bottom, I have x minus 1. That didn't cancel out with anything on top. And x minus 2. So remember that we are leaving these in factored form, which I told you is a good thing because you don't have to FOIL those out. Okay, so you're just going to leave those as factors. Remember, factors are what you multiply. Okay, so I'm going to have you start F. Okay, so go ahead and factor that. Okay, so Cole, how did you start this one? So walk me through your process. What did you do first?
Start with factor 2x.
And so what did you start in each parenthesis? Say it again. Okay, so if you're trying to multiply to 2x squared, what are the only two things that will multiply to that?
2x.
Yep, 2x and x. Okay, so now we want to find values that multiply to negative 4, but add up to negative 7. So if we are finding two values that multiply to negative 4, it's either 1 and 4 or 2 and 2. Keep in mind when you have a number that is not 1 here, you're going to end up multiplying it by this number. So I'm trying to get to negative 7. I know if I plug 4 in here, I'm at 8, which is close to 7. And this would be 1. I want it to be a negative. So if I make the 4 negative, it would be negative 8. This would be plus 1. Okay, so that's what you should have on the top. And then x minus 9 is the difference of two squares. So that is something we should recognize right away. We're going to multiply by the reciprocal. Let's actually do this part first, the 4x squared minus 1. Ian, what does that factor into?
That'd be 2x plus 1, 2x minus 1.
Yep, so this is also your special pattern, difference of two squares, because isn't 4 a perfect square? 1's a perfect square? Okay, now with this one, 8, I have options, right? 1 and 8, 2 and 4, but what can I do first that's going to help me? Yeah.
And take out the compound.
Yep, which is?
4.
Good. So can I take a 4 out of all of those? So if I take out the 4, divide by 4, I have 2x squared minus 7x plus 3. And then I'm going to factor that again. So 2x and x. I have a positive 3. This is minus, so both of those are going to be negative. It's either 3 and 1 or 1 and 3. If you put the 3 here, it gets multiplied by the 2. So you have negative 6 minus 1. And then we start the process. So 2x plus 1, does that cancel with something? Yes. Remember, they only cancel if one is on the top and one is on the bottom. What if they were both on the bottom? Do you guys know how you'd write that in your final answer? You'd do 2x plus 1 to the power 2, okay, squared, okay? That doesn't happen here, but that is something that you could see. X minus 4, nope. So then I write that down right away. 4, does 4 cancel out with anything or reduce at all? Nope, so that has to stay in front. So the numbers, the monomials always stay in front, okay, whether it's just a number or a variable. All right, and then x minus 3, can't put that away. Or I skipped one, right? 2x minus 1, does that cancel? Yep. X minus 3? Yep. And then, I don't have any, sorry. I don't have anything there. So x minus 4 times 4. On the bottom, I have x plus 3. So on the top, I have 4 times x minus 4 over x plus 3. So again, you're not distributing. You're going to leave that in factored form. So leave out the GCF. Okay, now for example 4, it says to solve and then check your solution. When you are checking your solution, you want to look out for restrictions that are in the domain, okay? So, we're working with rational functions. We know that the restrictions on our domain are going to be where the denominator cannot be equal to 0. So we want to find values that make it 0. The reason why we have to check our solution is because sometimes we have solutions that are called extraneous. So it looks like a solution, but when we plug it back in, it's not valid. Okay, so if we plug it back in and it's not valid, your final answer is actually going to be no solution. What I like to do is start off by looking at what my domain restriction is. So I have x minus 5 on the bottom. So I know that if I solve this, x cannot be 5. So if my answer is 5, I know I'm going to have no solution because that makes the denominator 0. All right, now there really are a couple different ways you can do this. If you had to solve this and the top was not factorable, do you guys know how you would move this out of the fraction? Multiply by the denominator. If you multiply by the reciprocal, you get 1, and then you'd have another fraction over here. So to get rid of the fraction, multiply by the denominator. You could also think of it as 14 over 1, cross multiply. That is something that we'll do later on. But this does factor. So, Ethan, what does x squared minus 25 factor to?
X plus 5, x minus 5.
Good, so that is your difference of two squares. And that is nice because in the denominator, we have x minus 5, so those would cancel. We'd have x plus 5 equals 14. Subtract 5 from both sides, so x is going to be 9. Okay, so we have to check to make sure that these are equal. So when you do your check, just show me what you're plugging in. For this one, I'm gonna write it out step by step, but when you're doing this on your homework, like 9 squared, you can do that part in your head. And then you are just going to simplify this side and see if it equals 14 or not. Okay, so it's either gonna equal 14 or not equal 14. So this is 81, we said. 81 minus 25 on top. 9 minus 5 is going to be 4. Remember, we're doing this without a calculator. So when you're subtracting, I would subtract 20 first. What's 81 minus 20? 61. And then, do you guys do this? If you have to subtract 5, do you subtract the 1 first to get to 60? And then you subtract the 4? So it would be 56. So I know I want this to be 14. Instead of thinking of the division, isn't it a lot easier to think of it as 14 times 4? Because 10 times 4 is 40, and then 4 times 4 is 16. So when you add them together, do you get 56? Yes. So those are going to check. So your solution is x equals 9. Okay, so then for B, again, the first thing I do is think about what my extraneous solution would be, okay? What can x not be? X can't be 2. Because if it was, 2 minus 2 would be 0, and that would be undefined. Okay, so now I'm going to factor. All right, now based on what we did here, what do you think one of your factors is going to be potentially? X minus 2. Okay, so that's 10, a negative 10. One has to be plus, one has to be minus. If you put 2 here, you have to put 5 here. Let's check. 5x minus 2x, is that 3x? Yes, it is. So these are going to cancel. You have x plus 5 equals 7. Subtract 5. Uh-oh. Okay, now we have x equals 2, but we said x cannot be 2, which means you are going to have no solution. This is what you have to do for your check. You can plug it back in and show that it's 0 on the bottom, but if you have already said what x can't equal, you can just show that x can't be 2, or you could write a statement. So when you're checking, you can say x can't be 2 because the denominator would equal 0. So x equals 2 is what we call extraneous. And that means there's no solution. Guys, some of you didn't write this down. You need to either write this down, or you can also, like I said, you can plug it in. Okay, so if you plug this in, the numeric value, you're just showing that you'd get 0 over 0, which is undefined. So again, no solution. This is extraneous. So if you were taking a quiz or taking a test on the line, you would put no solution. In your work, I would see that x is equal to 2. Okay, so you would need both of those parts. Okay? All right. I am going to put up the calendar so you guys can see your homework and our schedule for next week.